Hello dear students. Next we will look at the inverse kinematics of a spherical wrist. This is the last manipulator joint, not joint, this is the last manipulator that we are going to discuss because this is basically the wrist which is attached at the end of the arm. Because of the same reason, we are having the joints named as J4, J5, J6 because they are the fourth, fifth and the sixth joint. The wrist is always attached at the end of an arm. The arm will have three joints and the wrist will have three joints. These are the three joints. That's why it is written as J4, J5, J6 with joint variables theta 4, theta 5, theta 6. Based on that, the 3t6, suppose if it is given like this, which I have written it as equation 1, then our task is to find theta 4, theta 5, theta 6 based on this knowledge. As you can see here I have already written that AI and the link parameter table. The link parameter table is already discussed previously, so I have written it straight away, based on which we get the value of A4, A5 and A6 like this. You can try it on your own by substituting these values in the equation of AI. We will get A4, A5, A6. Again, why we have taken A4, A5, A6 is because these are the last three joints of the 6 degree of freedom robot manipulator. Based on that, when we multiply all of this, we will get 3t6 as this particular matrix, 4 by 4 homogeneous matrix, which you can see is quite complex. Now, based on this equation, the final equation, we have to find out what is the value of theta 4, theta 5, theta 6. Now, looking at this, you can directly see something that from above equation, from above, we can directly see that c theta 5, which is right here, c theta 5 is equal to r33. So based on that we will be able to directly find out theta 5 because it is present here. Therefore theta 5 is equal to cos inverse of r33. So doing that, we will directly get it. Now, once theta 5 is obtained, we can get theta 6 from this, or we can even go for theta 4. Let's go for theta 4. And C4 by S5 divided by S4 by S5, or let me take it as reverse. Let me first take, so what I am going to do here, I am going to take the division of this with respect to this, that is R23 divided by R13. So based on that, let me write the equation first. So I will get and S4 S5 divided by C4 S5, which S5 and S5 will cancel off. I will get S4 by S4, S4 by S4, not S4, C4, sorry, S4 by C4, which we all know is tan theta 4, and tan theta 4 is basically, according to this one, we have taken the division of these two, so we will directly write R23 divided by R13. Therefore, I can directly write that theta 4 will be equal to tan inverse of R23 divided by R13. So we have done for both theta 5 and theta 4. So let me put both of them in box so that we are okay. Now what is left is theta 6. You can use either this equation or even this equation. It does not matter because already theta 5 we have found out. So is there any other way? No, this is one of the most simplest way. So we'll directly take that. So let me write also. So also from above I can write S5 S6 is equal to, which can be written as sine theta 5 into sine theta 6 is equal to R32. Then from here we can say therefore sine theta 6 will be R32 divided by sine theta 5. Therefore, finally I can write that theta 6 will be equal to sine inverse of R32 divided by sine theta 5, which I can write it as sine. Okay, I'll write it as sine theta 5 itself. So this is the third equation. Because we have already found out theta 5, we will be able to very easily find out what is going to be theta 6. So with this we can very clearly see that we have found out theta 4, theta 5, theta 6. So this same thing we can apply for the case of the spherical wrist. Thank you.